All right, the big talk this week is the atmospheric river that's going to be moving into California, bringing multiple inches of rain to the central coast, up to maybe 5-6 feet of snow up into the Sierra. This is one of those events that, again, it's most likely going to lead to some damages and impacts in the short run, but then it's also going to lead to some good beneficial effects in the long run when it comes to things like drought, water supply, future wildfire danger. So atmospheric river is a very nuanced concept, so I thought it'd just be a good idea to dive into the science behind it and try to figure out exactly what it is. So we'll just go on over to Meteorology Insider here. What is an atmospheric river and how does it impact our weather? Have you ever heard of an atmospheric river? You definitely have if you watched the news the last week. We've been talking about it because it not only can lead to some damages just on itself, but if you've had a lot of rain recently, that means your soils are already saturated, so any new rainfall that comes is just going to instantly turn into flooding. So just diving back in here, that was an early tangent. It sounds like something out of a science fiction movie, but it's actually a real meteorological phenomenon that can have significant impacts on our weather patterns. In this blog post, we'll take a closer look at what atmospheric rivers are, how they form, and why they matter. So, atmospheric river, just right off the bat, to give us a brief idea of what goes on, you can just think of it as a river in the sky, and this brings a large amount of rain and snow to many different places across the world, but I mostly focus on California weather, so we're just mostly going to be talking about that throughout the course of this video. Atmospheric rivers are long, narrow corridors of water vapor in the atmosphere that transport large amounts of moisture from one region to another. They can stretch for thousands of kilometers and are often associated with strong storms and heavy precipitation. These events are also known as rivers in the sky because they resemble rivers flowing through the air. And I just heard a pretty crazy fact. You know how big the Mississippi River is? The daily flow of the Mississippi River, if you were to stop it at one point and see how much water flows across it, an atmospheric river is about 7 to even 15 times the flow of water that the Mississippi River is in a day. So that just gives you an idea. It's almost like having 7 to 15 Mississippi rivers above you, dropping that water over land. Now again, not all of that's going to fall, but the water vapor that does condense into liquid droplets, forms into clouds, that is going to fall as rain and then snow. And that's why these events are beneficial, but also hazardous. If you pick up that much that quickly, it's going to lead to some flooding, some landslides, but then it's also going to put a big dent in the drought. And I read one article earlier today that called atmospheric rivers drought busters, and that's definitely been the case throughout this year. The drought is looking great in California right now. It's completely gone in the Central Coast, but that's a topic for a video that I already did. So how do atmospheric rivers form? They typically originate in the tropics, where warm ocean waters evaporate and create moist air. This moist air rises and forms clouds, which are then carried along by the prevailing winds. As the air moves poleward, it cools and water vapor condenses, resulting in precipitation. That's a pretty good description right there, but they're kind of forgetting the most important piece, which is the rain shadow effect. So just going over the whole story of an atmospheric river, we start down in the tropics, close to the equator. Sun's beating down, that's where sunlight's the most direct, so you get a lot of evaporation, and you get all of this water vapor in the air, which is water in its gaseous state. Then it's picked up by winds, and the winds funnel that water vapor towards California. So as it's getting closer towards California, it's already going to start cooling down, and some of that water vapor is going to start turning into clouds, but then even more of it's going to turn into clouds when it bumps into the mountain ranges along the coast, but then also the mountain ranges in the Sierra. So what happens here is the water vapor is coming in. Here's your mountain. It's lifted up. As it rises, it cools. As it cools, it can't hold as much water vapor, so it turns into liquid droplets, which means clouds. And then right on that windward side of the mountain range, that's where you'll see the largest amount of rainfall. And then the same is true, so I'm thinking about the Santa Cruz Mountains right there, but then the same happens when it goes up to the Sierra, rises up, clouds form, you get a large amount of snow. Now, where there can be some damages in the Sierra, or where it can actually be a bad thing, is atmospheric rivers. As I explained, it's coming from the tropics. So it's bringing in a lot of warm air with it. For example, some of our temperatures tomorrow are going to be mid-60s, which is the warmest we've been in, I think, 2 weeks. But the reason that's bad in the mountains is all season long we've been picking up this great snowpack in the lower elevations, especially with the last storm we had where snow was falling even in the Santa Cruz Mountains. That's how cold it was. But when an atmospheric river comes in, it's associated with warmer air. So more of the precipitation is going to fall as rain. And then if you get rain on that snow, sometimes it just melts it right away, which can lead to more flooding because that's just stored up water. But the real concern there is then we have less of a snowpack later in the season, which the snowpack is crucial for continuing the supply of water to our reservoirs in a slow, orderly fashion, and then also slowly trickling out moisture into our fuels, which helps us in wildfire season. So the summary there in one sentence is atmospheric rivers are warmer, so you get more rain in the lower elevations, and that can fall on the snow and kind of ruin our snowpack in the lower elevations. So impacts from atmospheric rivers. While atmospheric rivers can bring much needed precipitation to arid regions, they can also cause significant flooding and other hazards. In fact, some of the most extreme weather events in history have been associated with atmospheric rivers. For example, in 1861 and 1862, I've read about this storm a little bit, a series of atmospheric rivers struck California, leading to what is known as the Great Flood. This event is estimated to have caused more than $10 billion in damages and resulted in thousands of deaths. I'm curious if that $10 billion is adjusted for inflation, but either way, this was a massive storm, 1861 to 1862. It's called the Great Flood, and you can actually look up some artist renderings of the state capitol where there's people in canoes going down the street, and it was some of the worst flooding that California has ever seen, if not the worst flooding we've ever seen. So more recently, in February 2017, an atmospheric river brought heavy rain and snow to California, breaking numerous precipitation records and causing widespread flooding and mudslides. In some areas, rainfall totals exceeded 20 inches in just a few days. These types of events highlight the importance of understanding atmospheric rivers and their potential impacts. So, yeah, atmospheric rivers with 7 to 15 Mississippi rivers flowing in, that's going to lead to a large amount of rainfall, which is good in a sense for water supply, drought, wildfire, but bad because you pick up so much so quickly that one, a lot of it runs off, and then two, you can get widespread flooding. So why do atmospheric rivers matter? In addition to the immediate impacts on weather and infrastructure, they can also have long-term effects on regional water resources. This might be where some of the good news comes in. For example, if a region experiences a prolonged drought, an atmospheric river event can provide a much-needed boost to water supplies. On the other hand, more bad news. If the region is not prepared for the sudden influx of water, it can lead to flooding and other hazards. So that is definitely a factor. We have many, many dams and reservoirs all across California, but I do believe that the majority of water still does end up flowing into the ocean. So in order to better understand and prepare for atmospheric rivers, scientists and meteorologists use a variety of tools and techniques. One of the most important is remote sensing, which involves using satellites and other instruments to measure and monitor atmospheric moisture and other variables. By analyzing this data, researchers can create models and forecasts of atmospheric river events, helping to inform decision makers and the public. So the main thing that I want to say about this, because obviously you know the gist of that, computer models, mathematical equations, observations, all go into weather forecasts that were used to predict what's going to happen when it comes to the weather. But the main nuance I want to add to this is the models get more accurate the closer to the event you actually are. So on Monday, everyone was already talking about the atmospheric river event, but when I was presenting it as a weather forecaster, I wasn't saying the exact time it was going to come in, I was using a very wide range when it came to how many inches we could get. I said, yeah, we could see more than a few inches with this. So very broad and general, because the models were still disagreeing a lot. Now, every single day, those models have narrowed in on exactly what's going to happen. And even the models today compared to yesterday shifted the event 5 hours earlier and bumped up our rainfall totals by about 2 inches. So as a viewer, it's important to remember this, that when you hear something maybe 5 days out, that's a bit early, and it could be a good indication that it might be a good idea to continue to watch the news and just maybe start to prepare. But the actual confidence in the forecast gets better the closer to the event you actually are. And as a forecaster, that's always a big thing that I think about, because you don't want, it's bad either way. If it ends up being a small storm and you said it was going to be a huge storm, you destroy your credibility. So then the next time there is a big storm and people should be preparing, you get that boy who cried wolf kind of aspect. But then in the other aspect, if early on in the forecast models they're showing a small storm, you say, oh, it's a small storm. And then as the models get more confident and accurate, closer to the event, it ends up being huge. Then there could be even worse impacts because people didn't prepare enough, because you had originally said the storm was going to be fine. And both those situations can hurt credibility. So that's why it's important to communicate confidence levels as a weather forecaster. Many days out, keep things general. As you zero in on the event, you can zero in on the exact timing and totals. Bit of a tangent there, but that's just something that I've been thinking a lot about. So, conclusion, overall atmospheric rivers are a fascinating and important aspect of our planet's weather system. While they can bring much needed precipitation to drought-stricken regions, they can also cause significant damage and hazards. By continuing to study and monitor these events, we can better prepare for their impacts and help to mitigate their effects on society and the environment. So, just the summary here. Sunlight goes into the tropics. You get evaporation, lots of water vapor. Winds funnel that water vapor into California. It's lifted up by the mountains. That leads to clouds, lots of rainfall, and then lots of snow in the Sierra. Systems are usually warmer than just your typical winter storm, so you can get more low elevation rain as opposed to snow. And then there's two sides to the coin. It's good and bad. It's bad because you pick up so much rain so quickly that it can lead to flooding, landslides, debris flows. And then they're also very windy. I don't think this mentioned winds at all, but you can also have some very strong winds with an atmospheric river. And then when the soils are saturated, it's easier for trees to fall over. So then you end up getting damages from that, and then also power outages as well when those trees and branches take out power lines. Now, the good news with these systems is just a few atmospheric river events per year bring about 30 to 50% of California's annual rainfall. So we need atmospheric river events. They're incredibly important to our water supply, and then it can also really help us out with the drought and future wildfire danger. And this year especially, we've seen the huge impact that it's had on the drought. At the beginning of the year, about, I think, 40% of the state was in extreme drought. Now 0% of the state is. So while it can lead to very bad impacts in the short run, in the long run, it's a necessary part of the California environment. So hopefully you learned something throughout the course of this video. I know I did, and thanks for watching.